Hello, my name is Dale Maley. In this video we're going to talk about some of the tips I've learned over the years on how to design and build wooden models or toys. Some background: I have designed and built over 40 hand-cranked wood models and more than 7 large hand-cranked wood models. Been a hobbyist woodworker for over 47 years, and I've learned many tricks from doing all these projects. So this video has many of these tips that I've learned. Many of these tips also apply to any general woodworking project. In my opinion, just one tip alone from this video is likely worth watching the video. I wish I'd learned some of this stuff many years ago when I first started woodworking. So in this video, I'm going to cover tips that I've learned from 14 different areas. And these include the list here, which is sources for model ideas, SketchUp drafting, wood selection, veneer, making small parts, sanding, gluing, and clamping, what type of finishes, lathe tools, router table, knee or paddle switches, Dremels, wood gears, and lubrication. So where can you get ideas on how to build your models or what to build? Well, here's a list of sources: books, woodworking magazines, YouTube videos, internet Google searches, a website called lumberjocks.com, which has many woodworking projects, SketchUp drafting program, their warehouse, and Pinterest. There are about 3 excellent books with many models you can build. The oldest one is this 1868 book, and it's 507 mechanical movements. And many of the concepts shown here can be modified to make hand-cranked wood models. A second excellent book as a source for wood models is this 1991 book, Making Mechanical Marvels in Wood, and it has many neat hand-crank models you can build. The third book for model ideas is this 2012 book, Building Wooden Machines, and it has 28 very neat hand-cranked models that you can build. For a drafting program, I use a program called SketchUp. And one thing I learned over the years is almost every plan that you run across will have some type of error in the plan. So for that reason, I usually redraw all the plans in SketchUp. It lets me find any errors before I actually build it. It helps me to understand the model better. And I also think about how I'm going to make some of the parts and how I'm going to assemble them as I draw them. SketchUp used to be free and owned by Google, but it was sold to Trimble Inc. in 2012. It's now an annual subscription business model. However, they do offer a free web version. I've only used it a little bit, but it appears to work. You still can get free version 7 up to version 14. I use mostly version 7. Sometimes I use version 14. SketchUp also offers a warehouse, so their users can upload models to the warehouse or download models from other users. So you could search the warehouse and see if you find some models you'd like to build. Unfortunately, most of the models are saved in the newer versions of SketchUp, not the older versions 7 and 14 that I use. There are some ways to get around that using converters you can find on the internet. But you can at least see the models and might give you some ideas for how you want to do your model. One nice feature of SketchUp, it lets you print out full-scale paper prints of unusual pieces you might have in your model. If your piece is larger than 8.5 by 11, you will have to tape multiple sheets of paper together, but that works okay. I glue those paper patterns onto the wood using white Elmer's glue. I then saw or cut out the piece, and there will be a little bit of white paper left over glued on the piece, so I'll rub that off using a wet rag. I often dry the part in my oven for about just 10 minutes at 120 F, but you can let it air dry also. Using the paper pattern is invaluable for making things like wood spur gears. Now there are other drafting software packages out there that you could utilize for your projects. Now let's move on to wood selection for your project. And deciding what wood to pick is actually driven by several factors. If you need a lot of mechanical strength for that piece, you might want to look at the hardwoods like red oak, white oak, maple, or hickory. Cost, Yeah, the hardwoods cost more than plain old pine, but the pieces are so small that the cost difference is really not that much. You can also use exotic woods in your model. For example, it might give you some nice natural color variation in your project. So Paddock starts out red, but it does kind of turn darker over time. Yellow heart has a nice yellow color, and it does not seem to change much over time. Purple heart starts out purple, but eventually it'll darken to dark brown. You can get a nice color contrast just using regular hardwoods. For example, maple gives you a lighter color. Red oak, you can use it natural or stain it to a color. Same thing with white oak. Now ebony is way too expensive, so one way to get around that, if you want a black part, is make it out of red oak, then use a black magic marker to turn it black, and then coat it with polyurethane and shellac to make it pop. You'll never know the difference between the red oak and the ebony. Another option for materials would be to use veneer. Veneer is very thin sheets of wood. It's relatively inexpensive. Over to the right, that picture is a lamp I recently made out of maple burl veneer. Another veneer is holly, which is very light colored. That can be used for decoration or letters into grooves in darker wood. Here's a photo of a small box that I made out of mahogany, which is the darker color. And then I used holly inlays for the pattern that's shown on the top. It really turned out nice. Here's the name of a company that I've used to provide the veneer for several of my projects, and they've always done an excellent job. Now, when you're making small parts, safety is a big issue. You want to be safe when you're making these parts. So always follow the safety recommendations of the manufacturer of any equipment that you are using. It's also a good idea to wear safety glasses and hearing protection. Now, in my experience, it can be a little more dangerous making small parts versus larger parts. Why is that? Well, there's not much to locate on. There's not much to hold on to the parts. And small parts can be kicked out, say from a saw, and fly away. So one general hint is, if possible, start out with a larger piece, do the work on that piece like routing, and then saw off the smaller piece that you want, and use the remainder as scrap or for something else. So how do you hold on to a small part that, say, you want to put on the router table and put some type of shape on it from the router? Well, they make a small part holder, as shown here on the right. Rockler sells a version of that. Other companies sell similar ones. I often use this on my router table if I need to hold a small part while I route it. Here's a photograph of the actual small part holding fixture that I use on my router table. As you can see, it's very similar to the Rockler one we just looked at. I highly recommend that you use push sticks on the table saw. Here's a photograph of the 3 push sticks that I use the most. The top one is relatively thin. It's made out of 3/16 inch thick Luan. I use that when I need to get the table saw fence within a 1/2 inch of the blade. The middle one, I actually use that most of the time to hold the piece against the fence so it doesn't move away from the fence. And my highest usage push stick would be the bottom one. It's made out of 1/2 inch thick plywood, and it's had many years of use. Sometimes on a model you need multiple pieces of very thin wood, and this fixture or tool is very handy. What it does, it lets you rip thin strips that are exactly the same width on your table saw. On your table saw, the wooden piece here I think is commonly called a throat guard. It's removable with a couple of screws. Anyway, you don't want to have your small part fall down in the gap there between the blade and the throat guard. So what you can do is buy these, or you can buy blanks too. Some are out of plastic, or you can make your own out of wood. And what you do is you install the blank on your table saw with the blade clear down, and then you start the saw and slowly raise up the blade, and it actually cuts a groove in the wood to exactly match the thickness of the blade. Another very helpful table saw accessory is this sacrificial fence. It's made out of MDF board, and it has the two blue clamps which let you quickly attach it to your fence. And it's very good for ripping thin places, and it avoids the whirling blade from hitting your metal fence. Here's a close-up view of one of the two clamps that you use to hold the sacrificial piece against your fence. The clamp just drops into a hole in the MDF board and you tighten up the knob. Another excellent safety tip on your table saw is to set the blade just high enough to saw the board. So on the left hand photo you can see the blade set way too high. It should be set more like the right hand side where the teeth are just above the wood. My friend Jeff did not take the time to lower the blade. He had it up high. He was in a hurry. And unfortunately, he reached over the blade and cut his hand. So I always take the time and lower that blade down just to try to reduce the chance of having any type of accident. Now I keep this little card on the wall next to my power tools. And what it is, it says, be aware of the 4 states. And those 4 states are rushing, you're in a hurry, frustration, fatigue, and complacency. And there was a company or a firm that studied a long history of industrial accidents. And they found out that those 4 states are what cause most accidents. I took a look at my own near-miss incidents that I had over the years, and I was surprised. Either one or more of those states were present when I had my near-miss accidents. So I hang this on my card. I try to be aware of the 4 things, and all of us probably get into a rush, or we get frustrated, or we're tired, or we're not paying attention. So just a very good reminder to have next to power equipment. I learned quite a while ago that of all my shop floor machinery, the one that gets the most hours of use on it is my floor mounted drill press. Why do I use it so much? Because I use a drum sander on it, primarily using 220 grit sandpaper to sand all my parts, including small parts. And in general, what you're supposed to do is start out with a rougher grit like 100, and then go to a second step like 150, and finish up with 220 grit. And once you're done sanding, you need to remove that sanding dust before you apply your finish. You can use a tack rag to do that, or often I just take a wet rag and wipe it off. Then I either air dry it or stick it in my oven for a few minutes at 120°F. Now on my drill press, here's that drum sanding attachment that I use, usually with 220 grit sandpaper in it. For about 40 years I'd have to cut the squares from the 220 grit sheets and then insert the cut sheet into the spindle drum sander. The bad news is the sheet does not last very long, and it's relatively time consuming to change out the sheets. Now just a couple years ago, I learned that a company called Klingspor, which sells lots of sanding supplies, looking through their catalog, and I found out they sell rolls of 220 grit, and these rolls are much stronger than the sheets that you buy. They last a very long time, and they're just great. I wish I'd known about this 40 years ago. It would have saved me a lot of time. Here's a photo of the setup I've been using the last couple years with the rolls of sandpaper. You can see the Klingspor roll up at the top, 220 grit. I have a wood block of the right size, so I can set that on top of the roll and then take a pair of scissors and cut out the exact right size I need for the drum sander, and then I can put it into the drum sander. Really works great. Now if I need to remove a lot of material, I can use one of these 2 drum sanders that I have. The small one is only 3/4 of an inch in diameter. The large one's 3-inch diameter, and those are replaceable sleeves. I usually use 60 or 80 grit, and boy, these will remove a lot of material in a hurry. Another machine that I use a lot making small parts is my stationary belt sander, shown here. It's about a 60 grit on the horizontal belt and maybe about a 150 grit on the wheel. There's also a Pro Stick abrasive belt and disc cleaner shown up there with a curved handle. That lets you clean the sandpaper and dramatically extend the life. It's a great tip to get one of these and use it. You could make your own attachment for the drill press that lets you sand inside smaller curved areas. All you do is take a 3/8 dowel, saw a slit down the dowel, and then slide in some 220 grit sandpaper into the slit and use it on your drill press. And it lets you sand inside smaller inside curves. Now let's switch gears and go into gluing and clamping tips. Here's the 3 types of glue that I have in my shop. The white Elmer's glue I use for gluing paper patterns onto wood. My main go-to glue for models and toys is Titebond 2, shown in the center. And I also have some Titebond 3, but I only use that on projects which are going to be located outdoors. Now there's a very old saying which says a woodworker can never have too many clamps. Here's most of my clamps, and keep them on a rack that I bought from Rockler. Now here's a great tip for something that I use on many smaller projects, and I call it the string and nail method of clamping. So you want to hold something together that's been glued, and you can't use straight clamps on it. All you do is get some medium duty string, put a couple of wraps around it, tie it in a knot, find you a large nail, and then stick it in and wind up that nail a couple of times. Now sometimes the nail will stay in place when it's wound up, putting tension on it. Sometimes you might have to use a little blue masking tape to keep the nail from unwinding. But boy, this is a super handy way to clamp up glued parts that are unusual shapes. Now I use about 4 different methods of finishing my projects. The first one that I've used for many years is sand the parts down to 220 grit. Then if you want to apply an oil-based stain on the wood or not, then apply your first coat of polyurethane, let it dry, sand to 220, put your second coat of poly on, let it dry, sand to 220 again, and put a third coat of poly on. This gives you a super smooth finish when you're done. My second option is sand it to 220 grit and just put 1 coat of shellac on a part. A third option is to sand it to 220 grit, put on some water-based dye to make the parts colorful, and then apply a layer or coat of poly or shellac. The fourth option is sand to 220 grit and simply paint the part. When you're finishing your projects, it takes a lot of time to let the different coats dry. So what I started doing many years ago, I have my own oven, not my wife's oven, and I'll place the parts in the oven way down to about 120 F, and for about 10 minutes you can dry about any of the finishes. Paint, however, you need to let it air dry for maybe half an hour, then put it in the oven for maybe 10 minutes. If you put the freshly painted part in, sometimes the paint might bubble on you and mess it up, then you have to fix it again. Now if I'm going to use polyurethane as a finish, I choose to use, and it's oil-based, I choose to use either semi-gloss or pure gloss, and one brand is shown here in the photo. I've tried water-based polyurethane. I got really bad results. I was disappointed. I did not get a shiny finish, and in reality I probably don't really know how to use it properly. I think you have to put a light coat on. It raises little fibers up, sand it again. Anyway, I choose not to use water-based products. I stick with my tried and true oil-based polyurethane. Now here's a tip for making the parts in your projects more colorful and making your overall assembly with many colors. And it's relatively inexpensive. What it is a powder that you buy in a bottle as shown on the left. You put just a little bit of that into with hot water and stir it up, and it makes a water-based dye. Now I store mine in baby food jars, but if they dry up it's no big deal. You can just add some more powder and more water and make more of the dye. Now you're likely going to need a minimum of about 2 coats to get a nice thick color on your part. And if you want, you can apply polyurethane or shellac over the dyed part. Now 3 or 4 years ago I tried using shellac instead of polyurethane for the first time, and I was really impressed because polyurethane is going to take you a couple hours to dry. You can speed that up by putting it in the oven a little bit, and you need multiple sanding and more coats. The shellac you put on, it dries extremely fast, like less than 15 minutes. You really only can put one coat on. If you put a second coat on, it just kind of melts into the first coat. Then when you're done, you can clean your brush with alcohol. And there's two types of shellac. I use the amber type shellac as shown in the photograph. I've really grown to like this for my projects. A lathe is a handy machine to have for making small parts. And my biggest tip about the lathe is what type of turning tools to use. You can buy the plain steel lathe tools fairly cheaply. That's the good news. The bad news is you have to resharpen them all the time. I bought some of the newer carbide insert lathe tools, and in my case I never really need to sharpen it. Now they are rather expensive to buy each one. I have about 3 of them, but I just love them because you never have to sharpen them, and they're always super sharp. A router and a router table is another great piece of machinery to help you make small parts. My Sears router table is shown in the picture, dates from the 1980s, and is a very simple router table. And then I have it raised up on a stand so the work height is normal work height ergonomically. It's an invaluable tool for making small parts. A few years ago I installed a knee switch or a paddle switch on I think on my router table first. And what it does, you push a push button with your finger to start the machine. Then when you want to stop, you don't have to use your hands, don't have to release them from the workpiece. You just take your knee and push in on the paddle switch. And I liked it so much on the router table that I ended up adding one to my table saw as well. And I really like that I don't have to take my hands away from the part when I'm done with the operation. I can just shut it off by pushing my knee against the paddle switch. It's a great accessory. Now I did not intend to make this video a Rockler commercial, but when I go through my shop equipment, I bought a lot of it from Rockler. They generally sell very high quality woodworking stuff. Anyway, I bought the paddle switches from Rockler for my table saw and my router. Now this is one tool that I could not hardly do without making smaller parts, and that's a Dremel. It's relatively inexpensive. It's high-speed spindle. And here's the 2 attachments I use the most on my projects. One is an abrasive tool, and you can buy different types and different sizes. They remove a lot of material in a hurry. The other one is the smaller 1/2-inch drum sander. And like I said, this is an invaluable tool if you're going to make small parts and small models. I utilize many types of wood gears in the models that I make. On spur gears, a brief outline of how I do those. I use a free program called Gear DXF that lets you generate the profile of the gear. I import that into SketchUp, scale it to the right size. Then I print out a paper pattern. I take that paper pattern and I use white Elmer's glue to attach it to the gear blank, and then I saw out the teeth on a bandsaw. I rub off any residual paper using a wet rag. Then you have to let it dry. I also utilize worm gears, which require the mating spur gear, in a lot of my models. And the reason is children can crank up to 100 RPM for short time periods. And most of my models need to run down something less than 10 RPM, which means you need a 10-to-1 reduction ratio. So worm gears are not easy to make, quite a few steps, too much to discuss in this video. But you can see other YouTube videos I made which explain in detail how to make both the worm gear and the mating spur gear. I also use a lot of brass screws in my model. They're very decorative, and they also allow you to take the model apart if you need to. But they're tricky to use in hardwoods, because if you just drill a hole and try to screw in a brass screw, you'll probably mess up the screwdriver slot, or you'll actually break the brass screw. So the process that I use is to drill a tapered pilot hole, and then I take a steel screw of exactly the same size as the brass screw that I want to use. I rub that steel screw on a paraffin block to give you some lubrication. I screw in the steel screw, and sometimes you have to do that in a couple of steps. But once you've got it down to full depth, you remove that steel screw and then take a brass screw, also rub it on a paraffin block for lubrication, and screw in the brass screw. As I said, if you don't use the steel screw first, you're extremely liable to strip out the head or actually break the brass screw. Here's a photo of the items involved with how I use brass screws. You can see the steel screw on the top, and to the right of it is the brass screw of the exactly same size. There's my tapered pilot bit that I use to drill the hole. Then there's a block of paraffin, which is available in grocery stores, to use as a lubricant. This process works very well. Almost all of my wood models and toys have moving parts, and they all need some type of lubrication. You can't really use oil-based or petroleum-based lubricants. They're too messy, they might stain the wood, etc. What does work real well is old-fashioned Johnson's paste wax. You can still buy it at Ace Hardware stores. I'm sure it's available at other places as well. Now, over a couple of years it will dry out in the can, but you can still keep on using it. Just take your finger and rub some out, and your body warmth almost melts it again, and you can keep on using it. I find it to be an excellent lubricant for wood models and toys. So in summary, this video explains many of the tips that I've learned to make it easier to make wood models or toys. You can also see my many other YouTube videos on my specific models and toys. I hope this video gives you ideas and helps save you time on your projects. I hope you enjoyed the video, and please subscribe. Thank you.